Okay, it's time for another tube time, like, oh my god. Welcome to Tube Time on Cool Dude Clem's Electronic Workshop. And I know it's been quite some time since I got these tubes here. I thought today I'd make the serious business push-pull tube amplifier. So, it's going to be made out of 3 tubes. This is one of them. This is a dual triode ECC83, I believe. Yes. That's an ECC83 little circuit that I made. This is going to be the phase splitter and first amplification stage, because I'm using one of the triodes as the amplification and the other triode as the signal splitter and phase inverter. I'll put up schematics later on. And these are the output tubes that I'm going to use. Now, I've already put sockets on both of them just to make sure they both fit okay. This is a 6N3C or whatever that means. I don't read Russian. I think that's actually 6R3P or something. I don't know. But what I do know are these are high power pentodes. I mean high power beam tetrodes, which will work well in an amplifier, and they even come with a spec sheet, so I know what all the pins are. And yes, it's in Russian, but I speak the universal language of electronics, so it doesn't matter. And on the other side, got everything I need to know. And looks like we need negative 14 volts of grid bias, so I'm going to use a cathode type bias by putting a resistor between the cathode and the ground, and that will give us our grid bias as well. Alrighty then, what I'm doing here is I want to find out what cathode resistor I'm going to use, because I'm going to use cathode biasing, which basically means putting a resistor between the cathode and the ground, so the cathode is at a higher voltage than the grid. So instead of having to apply negative voltage to the grid, all I have to do is make sure that the cathode's voltage is, well, in this case 17 volts, because that's, according to the data sheet that came with this tube, that's the bias voltage we need. So if the grid is at 0 volts and the cathode is at 17 volts, then the grid's voltage relative to the cathode is going to be negative 17 volts. And that's what we need. So what I'm going to do is measure the voltage that we see across this resistor. I'm just going to wait for that to get up to its full temperature. And if the voltage across this resistor is too low, then I'll use a resistor of a larger value. If the voltage across that resistor is too high, I'll lower that resistor. So anyway, I'll go over the circuit while it's warming up. So I've got the positive, which is going to come out of the high voltage supply. It's going into this transformer here, which I'm just using as a dummy load. Then out of the transformer, into the anode, or the plate, whatever you want to call it. Also, some of that positive voltage is going into this 10K resistor that I've mocked up. So that's going to feed our second grid. I've got the first grid, or the control grid, whatever you want to call it, connected to ground through this resistor here, which is a 470K. Doesn't have to be 470K, it can be anything really from 100 kiloohms to a megohm in most cases, and I'm using a 470 ohm to connect the cathode to the ground. Okay, so I'm going to turn on the high voltage. That's had plenty of time to warm up, and let's see what voltage we get across the resistor. Onto this we've got nothing at all, because I forgot to plug it in, because I'm an idiot. It's no wonder it's not doing anything. Right, so got my high voltage power supply plugged in now. Turn this on and we'll see what voltage we get across the resistor. Okay, Seems to be dropping for some reason. Okay, there we go. Okay, we got over 20 volts going through that, so we need to use a smaller resistor. Let's just see what the voltage is. Let's just turn the power on again. This power supply is a bit dodgy actually, for some reason. It's come on, work. There we go. Got a bit of a dodgy switch. Okay, so we got 21 volts there. Okay, so ideally I think I would need a 330 ohm resistor there. That's the next value I would try. But anyway, as it is right now, this would probably do some amplifying. I'm going to turn that on again. Turn on the power. I'm not hearing anything from the speaker, not even a slightest faint buzz. Don't know if that resistor's going to burn up on me, but we'll see. We've got 21 volts going across it. Now I'm going to touch the grid with this wire here. See if we get anything out the speaker. Okay, it's good, it shows it's working. Okay, well let's try playing some music through this thing as it is right now. Now I've got my reel-to-reel hooked up, coming through this capacitor here. So this is from the reel-to-reel's line out. Alright, so I'll start the reel-to-reel playing. Let's see if we get any sound out of this thing. I don't think it's going to be very loud at this point, but let's have a listen anyway. Okay, there it is. Don't know if my ugly face is getting in the shot. Okay, so we know that works. That should be a lot louder once I put a capacitor across that resistor. Alright, okay, there we go. Put a 470 microfarad capacitor across there. Making sure, of course, that it's at least 25 volts. And the polarity's right, because we don't want anything exploding now. Should be a little bit louder now. It's definitely louder. Well, anyway, enough about that, because now I want to get on and build the actual output stage. Okay, now it looks like we got something. Yes, I know I'm using cardboard, but I think it'll work well enough. Okay, pull the camera back a bit so you can see a bit more of it. Haven't put in the phase inverter circuit yet, but I'm just testing that both sides of the output stage are working, so I'll just touch the base. I'll just touch the grid of each tube. Let's see if we get anything out of the speaker. Okay, that one's working. Let's do the same with this grid. This tube. And that one appears to be working. So, next thing to do is put the final piece of circuitry in. And we'll see how well this thing works. Okay, I have built it. And it's working. Now I want to do this quick because I've only got everything put in with hot glue. So I just want to do this video quickly and then get everything put in properly before the glue melts. So put in the phase inverter and splitter and preamp circuit right there and everything else you saw earlier. Put in the volume control, which goes into the grid of the cathode of the 12XA7 or ECC83, depending what you want to call it. And it works. So let's give it a listen. What does the bird say? Oh please, not that! Anything but that! I cannot apologize enough for that atrocity that you just heard. So let's do a proper test with this amplifier. Okay, I don't know what was going on there with the recording, but I can tell you, this thing is so freaking loud. That's better, that's a more suitable volume level. Don't want to annoy the neighbours now, do we? Also, I don't know why this recording keeps dropping out and coming back. That's actually on the actual tape itself, it's nothing to do with this. So I'll just stop that. And there we go, there is my push-pull serious business tube amplifier. Still got a little bit of refining to do. I mean, after all, still need to get the bias voltages right. Now I will admit, I made a little mistake, because somewhere along the line I forgot what the bias voltage should be, and I thought it was 17 volts when in fact it's supposed to be 14, but I've decided to leave those 470 ohm resistors in, because with the addition of the other tubes that's going to pull the power supply's voltage down a bit, which is also going to lower the voltage across those resistors. So I thought, let's see what the voltage across those resistors is now and go from there. Now I'm just going to take this meter, I'm going to put it onto volts. I'm just going to measure across one of the resistors to see what our bias voltage actually is, hopefully without making something go bang, because I don't really like that. I'm allergic to sudden loud noises. Okay, 13.5. Well, that's close enough. I mean, that could do with about 500 millivolts more, but I don't think that's going to make any difference, really. So I guess you're desperate to see this from the other side, so I don't just see all this manky wiring here. Well, let's take a look. Here we go. This is the amplifier that I made. I don't know where the microphone is, so I'm just going to have to talk like this. That's it. Now, I don't know why my volume controller's going in at such a weird angle. But then I am only making this out of cardboard. And some people might scoff at that, but I'm just doing what I can with what I got. And here's how it looks from the top. Two output tubes, which are probably still warm from the previous run. So there's a 12XA7 or ECC83. One of the capacitors and the transformer. Now, I know that transformer that I've put in there, focus, I thought I'd turn the autofocus on this thing off. Actually, it's that way. Now I know this transformer isn't the best type of transformer for this amplifier, but at the moment that's the most suitable one I have, so that's the one I'm going to have to use. I'm sure with a much better transformer this will be even louder and more bassier. Not that it didn't have plenty of bass already, but still. So anyway, I'm going to say I'm quite happy with that. Now I'm going to have to do is make this look a bit better, and it's going to be really good, but that's going to be for another video, because I'm sure this has taken up too much time already, rabbiting on again like I normally do, so yeah. And for those of you interested, here is the full schematic of the amplifier, which I'm going to leave on the screen for a few seconds, so you can just pause it and ponder over it if you wish. Anyway, I've got to go now, so until next time, goodbye. Okay, we're just testing here. Testing the amplifier. Because I've got to say something again. Because for some reason, even though I know I said the right words, the computer decided to re-edit my words, unbeknownst to me. So I've got to say that whole line again and hope the computer doesn't screw things up. Alright, and it's time for another tube time on Cool Dude Clem's Electronic Workshop. Welcome to Tube Time on Cool Dude Clem's Electronic Workshop. Today I thought I'd revisit the base-fed Well, I don't really know if you can call this a Tesla coil, because it's not, technically it's not a Tesla coil, because it's not a transformer, and it works on a completely different way than a Tesla coil works, so I don't really know, but anyway, for now we'll just call it a bottom-fed vacuum tube Tesla coil. Now, I'm at a point now where I do get a plasma flame, because I've been experimenting with various different coils and seeing what gives me the best results. Now, these aren't the two coils that actually work. I'm just curious about how this is going to, what I'm going to get if I use those two coils. But I'll just take you through a brief tour of the circuit. Now, I'm sure you're curious about what's in this black box here, so I'm going to open that up and show you. Now, this is the high voltage part of the power supply. Got two transformers back to back, so I've got mains going into this transformer here. Then it gets converted to 24 volts. Then that 24 volts goes into this transformer, where it gets stepped up to about 250 volts, because they're not exactly matched, but it's close enough. And then I've got a whole boatload of capacitors and some diodes. And what that is, not a voltage doubler, it's a voltage tripler, which will give me 3 times the peak voltage of the AC, which is going to be around 1000 volts. Now, I know some of you are going, oh my god, it's 1000 volts, he's going to kill himself. Please, yes, this is a little bit dangerous. However, it's no more dangerous than crossing the road, and I should know, because I have been hit more than once while crossing the road, and I'm still here, and that's a lot more dangerous than this is. So, no need to be concerned about my safety. At all. I mean, I'm not going to do something stupid like hold the screwdriver by both hands and touch one. Ow! Just kidding. It wasn't even on. But seriously, I do take safety steps before I do any of these experiments. I always keep one hand in my pocket or behind myself. If I should touch anything live, it's only going to go into one hand. It's not going to go all the way through my body. And I'm pretty well insulated, so, again, no need to worry. But anyway, with that little ramble about you all being concerned for my safety, well, now you know. So we got this as our high voltage power supply, and this transformer here is just to power the filament, and I've just taped these windings to the wall because I'm not using those. I'm only using one set of output windings. So anyway, this is the circuit itself, and I've decided that because I'm going to be testing different coils, I'm using crocodile clips, so I can quickly and easily swap out the different coils and see which works best. Now, we'll put up a schematic of this circuit. It's pretty much the same vacuum tube, base-fed vacuum tube Tesla coil thing that you've seen 1,000 times already, but I will just do a little demonstration right now. Alright, so let's see how this works. And I've also taken Robot797 has also given me some advice on how I can film this, because I had trouble filming this. It would always make the camera glitch out, and he suggested that I should wrap the camera in foil and then ground it. So hopefully that's going to sort out that little problem. Surprised I didn't think of that myself. I'll turn this on and we'll see if we get anything. Okay. I can draw an arc off that. It's not starting a flame though. You probably heard a very loud buzz on your end, because this circuit likes to throw out a ton of interference. Right, let's see what happens with a light bulb or a fluorescent tube. I'll try and hold it. Okay. Wow, there we go. Actually, I've just turned it off and the tube is still on. I can still see a bit of glow out of that. That means that's not pulling much current. Actually, I wonder if I put that in there, in the coil, just see if that will light up. I think it will, but let's see. Oh yes, that totally lights up. Just turn the power off and just, wow, just look how long that's taking forever to go out. That's just running off the energy in the capacitors, and it's still going. I can still see a little bit of light right at the end there. I know you cannot. Okay, there it goes. It's gone. That must have been well over 10 seconds for this thing to go completely out. Just out of curiosity, let's see what happens if I put it in this coil, which is the inductor. Let's see if it lights up if I put it in there. And yes, it does. Let's see how long that takes to go out. Still going. Still going. It's still going. Okay, there it goes. It's gone. Alright, well, we know that works. So, next thing to do now is to put in the coils that I know work so far and see what it does. Okay, I've replaced the coil with this coil here, which is much more suited for this kind of circuit. So, that's an entirely different resonator. Change the inductor to this one here, and this one does produce plasma. Okay, safety's off, high voltage is on, and there we go. Flames. Now it does go a little bit weird if I put more power into this thing, because I am powering this through my heater, which I'm using as a ballast. And even with all this foil wrapped around the camera, it still manages to interfere with it. So I'm going to try and record a stronger output. Yep, it doesn't like. My camera does not like this. And I cannot stop it recording. Yes, this thing has knocked out my mouse. Okay, so we know that works. Unfortunately, I couldn't film it with the camera. I don't know if you can hear that incredible noise in the background, which is Family Guy. But you probably heard an incredible screeching noise coming from this flame when I put it on higher power. Which usually means that the resistor I'm using here is too high. So I might try lowering that and see what happens. Unfortunately, we couldn't get video of it because it still messes with the camera, and also it knocked out my mouse. So I had to unplug that and plug that back in. Okay, so I decided to do something about the screeching flame. So I dropped the resistor down from 220 kiloohms to just 100 kiloohms. Now that seems to have stopped the incredibly annoying noise that it was making. And also, my mouse didn't conk out this time, so I'm going to see if we can record this. Safety is off. So, low power, medium power, and full power. That is just amazing. It didn't make the camera glitch out. Alright, so it's time to conduct a little scientific experiment. I have made 3 coils, as you can see here. These are going to be my chokes, and I'm going to test each one of these. So this one here, because it's wound on the same diameter form, uses the same wire, and has the same amount of turns, that has exactly the same properties as my output resonator. So this will have the same inductance. This one only has half as many turns, so that's going to have around half the inductance. And this one, which is 54 turns, has twice as many turns. In fact, I had to use 2 pieces of wire because one piece was not long enough. and that will have about twice as much inductance, so we're going to see which one works best. My money's on this one, if I was to make a bet. Okay, so here we are with the 13-turn choke, not producing much output at all, so let's go over to the 27-turn. That's much better. In fact, that's about the best I've gotten so far, and I'm only doing this on low power. This is not even on high power. And finally, the 54-turn. So, well, it's very close, but I'm going to say that's not quite as much output as we got with the 27-turn choke. So, that's the one I'm going to use. Now, I'm sure some of you are wondering what this little thing is all about, and why there is a Walkman beside it. Well, that's because I'm going to try and go for audio modulation with this thing. So what I've done is I've disconnected the cathode, and that's going into this little circuit here, which is made of a MOSFET, a couple of resistors and a couple of capacitors, and yes, I've done the most sinful sin of all. I'm mixing tube state with solid state. However, it doesn't seem to work all that well. Now, I'm just going to move this out the way, because that will get seriously interfered with. And I've been having trouble getting these videos recorded, because it keeps interfering with my camera. I'm going to show you this thing in action now. Now, you've got to remember that the output's not going to be anywhere near as big as it was before, because it's going through this, which you cannot even see because of the camera. Now, this paper that's under it is doing absolutely nothing. That's just there to stop it wobbling about, because every time I touch this, because it's on a piece of glass and because it's not completely straight, it chatters about like crazy and it's irritating me. But anyway, I'll just turn this on and you'll see. And you can see there's a tiny little bit of plasma on the end there. I'm having to re-record the commentary because this interfered with my microphone like you would not believe. But anyway, if I adjust the potentiometer here, I can adjust the size of that. Makes a really weird noise around there. I don't know what that's all about. But as you can see, that actually does work. Alright, we lost it. So I'll just turn it off. But by modulating the input going into the gate there, in theory, I should be able to audio modulate the output of this thing, although it didn't actually work as good as I thought it would. Did you hear my stomach just then? Okay, so I have to go over to the camera's microphone now because you couldn't even... I just played back the previous video and I couldn't even hear a word I was saying because this makes so much interference, but the webcam's microphone might fare a little better. Again, this is only at low power because I found out that this resistor gets incredibly hot. So I'll turn this on, make sure we've got output. Alright, so there we go. Now I'll play something. Oh, we lost it. I just have to reignite. But I cannot... I mean, that Walkman's on the highest, on full volume right now, and I just cannot hear anything. I did get a little audio modulation earlier, but I don't seem to be even able to get that now. Okay, try one more time, because we should be hearing AC/DC's High Voltage, which I thought would be a perfect song to play through something like this, but it doesn't seem to want to cooperate. Strange thing is, I can hear something that sounds like the Walkman's motor playing through that. That's about all I can hear. Just kind of odd. just check that I haven't nuked this thing or something. I'm just going to connect a little speaker up to it and make sure that's actually still working. Okay, I thought I'd end this by showing some schematics. So this is the schematic of the power supply, and look at that. I've calculated over 1,000 volts. Well, 1,050, but it's going to be about 900 volts when it's under load. So what we've got here is two transformers back to back. Got a mains transformer here, stepping it down to 24 volts. And it's a center tapped transformer. In fact, they're both center tapped transformers, so that's why they're connected up this way. So 240 volts going in, 24 volts going out, 24 volts going in, and 250 volts coming up, because there's a little bit of an imbalance there, but it works. And from there, it goes into a tripler, which rectifies and triplicates the voltage. You might be thinking, well, there's 250 volts, so if you triple that voltage, well, shouldn't it be 750 volts or something like that? Maybe. But you've got to remember, it's AC coming out of those transformers. 250 volts is just the average voltage. The peak voltage is about 1.4 times higher than that. So what we've got is 3 times the peak voltage. And because I don't have enough 400 volt capacitors, apart from that one there, I've had to string a bunch of 200 volt capacitors together in series, which is all these capacitors along here. And these resistors do 2 jobs. One is they act as bleeder resistors, so when the thing is unplugged, they'll bleed the voltage down, so after a few minutes or so it'll be safe to touch. But also, it makes sure that the voltage in each capacitor is the same. So we don't get one capacitor more charged than the other one, because that could be bad. Really bad. And this is the Tesla coil, if you want to call it that, itself. As you can see, it's a very, very simple circuit. Almost nothing to it. So I'll just let you ponder over that. But anyway, if I disconnect the cathode from the ground, I can insert this circuit. So now you can see it a little bit more clearly. So audio goes in, modulates the voltage at the gate of the MOSFET. And I can set the flame size by this variable resistor here, but it didn't work. I was able to set the flame size, but didn't get any audio modulation. So anyway, there's the circuit. Yeah, like I said, didn't work, but here it is anyway. Anyway, that's just about it for this video. There is another base-fed Tesla coil that, well, even I made the mistake there saying Tesla coil. There is another base-fed coil that I want to try, which I'm not going to show you just yet, because I want to put it together and make sure it works, and if it does, that's going to be in an upcoming video. But this video is getting too long already, so I'll sign off now by saying what I always say. Until next time, goodbye.